Good to have you back for example 4, more with finding intercepts and using those intercepts to graph our lines. All right, let's do it. In this example, you'll notice that on both sides of our equation, we have something that involves x. Nothing to be alarmed about. We're still going to solve for our x-intercept and y-intercept the same way we have in the previous 3 examples. If the minus 2x really bothers you there on the right, you could add it to both sides. So you have it in what's called standard form. The equation of your line would be in standard form. And standard form just means you have the letters on one side and you have just a number on the other side, a constant. And a constant just means it's a number without a letter, basically. All right. Now, if we're going to plot by intercepts, we need to find the intercepts first. And to find our x-intercept, how do we do that? To find the x-intercept, we ignore y. Anything that involves y, we ignore it. And what's remaining is the equation that we need to solve to find our x-intercept. So what's our new equation? 6x equals, ignore that y stuff, negative 18 minus 2x. We have x's on both sides, no big deal. We'll just shuffle the 2x from the right to the left, to the left, to the left. Those are going to cancel. 8x equals negative 18, right? Divide both sides by 8 to get that x all by its lonesome. We're almost home free. Uh-oh, wait. 8 doesn't divide into negative 18 evenly. What does that mean? It just means 8 doesn't divide into negative 18 evenly. It means we can still solve this problem. That's okay. What we want to do first is, just so we stay in that groove of reducing fractions, let's reduce negative 18 over 8 first. And that's going to be the opposite of 9/4, negative, and then 9 over 4. Now, the problem is this is somewhat difficult to interpret. It seems weird. How are you going to plot negative 9/4 on the coordinate plane? And another danger is you might interpret this as the slope, since we like to have our slopes as fractions, rise over run. But this is not a slope. This is a point in the coordinate plane. And so what we actually want to do is rewrite this as a decimal. And negative 9/4 is negative 2.25. This is much easier to interpret than negative 9/4, at least as far as where this number actually is on the coordinate plane. And if we are looking for the x-intercept, once we find it, we know that y is always going to be 0. Now, to find the y-intercept, what do? Ignore x. If I want to find y, anything that involves x, I ignore. And my new equation is what I need to solve to find what my y-intercept is. Excuse me. Okay, that looks nice. Isn't that nice? Divide both sides by negative 3, and look at what we get for our y. Get a nice number. We get y equals 6. Okay. All right. Now, if our y-intercept is 6, what is x going to be? X is going to be 0. Doesn't matter what your y-intercept is. The y-intercept could be anything. The point is, if you're talking about the y-intercept, x is always 0. All right, we've got our 2 intercepts, and now we can finally graph this line using those 2 points, those 2 intercepts. That's what we want to do next. All right, let me get a coordinate plane going on here, and why don't you guys write a coordinate plane down for yourselves while I'm doing this one. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. And I'll admit I've been kind of lazy on the previous videos. I probably should be labeling at least some of these tick marks so you understand that how I'm scaling them. If I don't scale a coordinate plane, if I just leave the numbers off, it's safe to assume that I'm scaling them by 1, but it is better if you actually show us specifically how you're scaling. All right, anyway, let's get this thing plotted. Let's get our line graphed. Let's start with the harder one first. Our x-intercept is negative 2.25. Yuck. How do I plot that? Clearly, it's going to be between negative 2 and negative 3. But what am I closer to? Am I closer to the negative 2 or the negative 3? I'm closer to the negative 2. If I were halfway between, I'd be at negative 2.5. And if I were even closer, I might be something like negative 2.6, negative 2.7. That's going to be closer to negative 3. So basically what I want to do is, since I'm looking at a quarter here, 0.25 is a quarter, I want to be a quarter of the way to the left of negative 2. So picture from negative 2 to negative 3 being broken up into 4 slices, four pieces, let me say, not slices, but 4 pieces. I want to be a quarter of the way to the left of negative 2. And again, it's okay if it's not like perfectly in the right spot. I understand that when you're plotting that point that you mean negative 2.25. So you just do the best you can. And then our 0, 6, that's going to be easy, but look at what I did. I didn't go up high enough. 5, 6. Okay, I'm sorry for that. Apologies for that. I hope you can see that. This is where 6 is going to go. 0, 6 on my y-axis. And now I'm going to connect these 2 points as best as I can. And there you have it. There's our line. There's our line graphed using the intercepts. And this example is done. One more example to go, guys, and then we are home free. So stick with me a little bit longer. See you soon. Bye.